Hello, everyone. I'm Freddy Gabbay, and I'm going to present our work on Risc-V and Machine Learning Accelerator Hackathon, enhancing undergraduate students' perception of essential chip design skill. The work was done jointly with Benjamin Salomon, Rafi Cohen, and Stav. This work was done at the Ruping Academic Center at the Engineering Faculty in conjunction with the Artificial Intelligence Lab. Moving to the agenda of this talk, then we will start with introduction and background. Then I'm going to discuss the motivation and goals. Next, I'm going to talk about the hackathon challenges. And after that, I will present the student assessment process and our finding. I'll conclude this talk by presenting our summary. Let's start with introduction and background. Chip design engineer shortage is continuously growing all over semiconductor industry. The shortage is even worse in core technology positions such as RTL and physical design engineers, layout, architect, and verification engineers. The shortage impact on the semiconductor industry is huge. It induces schedule delays and revenue losses. The talent shortfall starts with college graduates. This is due to the growing complexity of advanced VLSI chip design, and also due to the competition with emerging fields such as AI, cyber, mobile, and software. Due to this reason, it may discourage students from broadening chip design knowledge and skills. This slide further emphasizes the shortage of VLSI and electrical engineer. The slide illustrates the percentage of companies that have difficulty filling open positions by discipline. And as it can be observed, the gap in electrical engineers, the gap for electrical engineers is the most noticeable one across all other disciplines. So moving to the hackathon goals, we define several goals for this event. The first is to intensify undergraduate students' understanding of digital hardware design skills. Second is to expose students to new and emerging fields such as Risc-V, Accelerator, and software-hardware interaction. In addition, our goal is to enhance student perspective of essential and soft skills importance along the design process. In addition, encourage success experience, and last, fun. Moving to the hackathon technical challenge, the hackathon was based on an FPGA board, which was distributed to every team that participated in the hackathon. The board was based on Terazic D0CV FPGA board with Altera FPGA. The development platform that was used by the hackathon participant was based on Intel Quarter FPGA design software, where for this platform, all participants got a Risc-V Verilog model of a Risc-V microprocessor, which was prepared prior to the hackathon event. And they were required to develop an accelerator model, which was embedded with a Risc-V microprocessor. In addition to the Quartus development environment, all participants were provided a C compiler with a sample C program, which they were able to run on the Risc-V microprocessor. The participants were required to develop an accelerator which will perform a matrix multiplication to accelerate the inference process of a provided neural network. Moving next to the pre-hackathon preparation process. A hackathon website was created for all participants. Through the hackathon website, all students could enroll to the hackathon and make their registration, up to 3 students in a team. In addition, they could download the development platform and the Risc-V Verilog model. And also, the website provided an online training videos and materials. In addition, we conducted an online Zoom meeting that offered further training and installation guideline by the hackathon mentor. And finally, all participants were required to run a simple C program to ensure that all components were fully operational. Moving next to the student assessment process. The participant in the assessment process included 30 students from electrical and computing engineering department, ranging from junior to senior years. Student assessment was performed prior and after the event, and it consisted of two parts. In the first part, a questionnaire comprising perception of 20 challenge success factor importance, like a 5-point Likert style, where the 20 assessment reflected 3 different categories of essential skill: self-management and persistence, interpersonal and communication skill, and technical and engineering thinking. In the second part, an open-ended questionnaire collecting students' prior and post-event views, focusing on the opinions of the most necessary skill for a successful challenge, and also emphasize any experience change following the event participation. So moving to the first part of the analysis of the statement grading data, we observed that the most meaningful observation for perspective change by the student involved the following factor: the ability to secure knowledge and technical resources for the project. The score changed from 3.6 to 4.6 prior and after the event, respectively. This might be an indication that participant mindset changed from viewing the challenge as a personal one to a wider team challenge. As for the rest of the essential skill listed, many of the students retain a similar important grade pre and post the event, with a mild upward estimation of some essential skill significance. If we take a further look on the analysis of statement by category, we observe that software skills of the two categories related to teamwork and higher level thinking were the most intensified skill acknowledged as a result of participating in the event, while the assessment of self-dependent skill remained unchanged. In the second part, we performed an analysis of the open-ended qualitative data. The analysis process was performed per every participant, as is illustrated in this slide. Our main finding is that most of the team found the technical hardware somewhat highly challenging to overcome. Yet students that demonstrated persistence found support through teamwork collaboration. Those, in contrary to their initial trust in sole personal ability. Before moving to the summary part, you can see the participant of the hackathon event in the final ceremony part, where the winner of the hackathon was announced, accompanied by staff members and mentors. Moving to the summary part, the hackathon aimed to strengthen students' interest in chip design, offer a unique team of design of a Risc-V processor with a machine learning accelerator, emphasize the importance of system-level consideration and software-hardware interaction, and enhance student understanding of the importance of teamwork, self-management skill, and inter-team communication. Our finding indicates that students encounter significant technical barriers. Teamwork and system-level thinking were the most intensified skills experienced by the participant. Corrective action for the next event that is going to take place on April is to consider a different preparation approach, which will include a preparation assignment in stress-free environment. In addition, we would enhance the inter-team collaboration during the hackathon. For example, help participants leverage insight and lesson learned by their colleagues through the hackathon. Thank you everyone for listening for this talk. You can find here my contact details, so feel free to send any questions or any comments. Thank you.